Good day, everyone. I'm Zia Thawin, and I'd like to welcome you to Chapter 1 of Industrial Engineering and Management at Qualitas School of Business and Technology. Today, we are going to begin our journey into understanding how industrial engineering shapes modern business operations and production systems. I find this subject particularly fascinating because it combines the precision of engineering with the strategic aspects of management, something I have experienced firsthand throughout my career. Before we dive into the technical content, let me share a real situation I encountered recently. I was working with a local manufacturing company that was struggling with production delays and quality issues. By applying industrial engineering principles, we not only solved their immediate problems but also helped them establish a more efficient production system. This is exactly the kind of practical knowledge I want to share you throughout this course. With my background in engineering, law, and business administration, along with practical experience as a Lean Six Sigma Master Black Belt and Chartered Quality Professional, I will be bringing diverse perspectives to our discussions. This is not just about learning theories, it's about understanding how to apply these concepts in real world situations. Throughout this course, we will explore how industrial engineering principles can transform organizations, improve efficiency, and create sustainable production systems. I encourage you to ask questions and share your own experiences as we go along. Shall we begin exploring how industrial engineering is revolutionizing modern production systems? This introduction combines my credential with practical experience while setting expectations for the course in an engaging way. Hi everyone, before we begin, I want to mention that I won't be reading directly from these slides. Instead, I'll be sharing real world examples and scenarios to help you understand how industrial engineering works in practice. Today, we are going to dive deep into industrial engineering, examining how transform organizations throughout systematic optimization. Let's start with a real world scenario. Imagine a busy restaurant kitchen during peak hours. Industrial engineering principles can help organize everything from food preparation to service delivery, making the entire operation more efficient. So let's break down each core components of industrial engineering with practical examples. When we talk about utilizing man or human resources efficiently and effectively, consider a manufacturing plant where workers were experiencing fatigue due to repetitive motions. An industrial engineer might redesign the workstation height, implement job rotation schedules, and introduce ergonomic tools to improve both worker comfort and productivity. For machines, think about a printing company with multiple printing presses. An industrial engineer will analyze machine downtime, maintenance schedules, and production speeds to maximize equipment utilization. They might implement predictive maintenance systems that prevent breakdowns before they occur. Regarding materials, consider an automotive assembly line. Industrial engineers work to ensure parts arrive just when needed, reducing storage costs while preventing production delays. They might implement inventory tracking systems and optimize supply chain routes. Information management could involve design a hospital's patient scheduling system. Industrial engineers would create workflows that reduce waiting times, ensure efficient use of medical equipment, and maintain high quality patient care. Energy utilization might involve analyzing a data center's power consumption. Engineers will study peak usage patterns, implement cooling system and optimization, and recommend energy efficient equipment upgrades. Management and operations conditions. So, for example, let's explore how industrial engineering connects management goals with operations performance through a specific example. Suppose a company's management sets a goal to reduce production costs by 15% while maintaining quality. The industrial engineer could analyze current production processes using time studies and workflow mapping. He will identify wasteful steps or inefficient methods. Then he will implement automated solutions where cost effective. After that, redesign work processes to reduce unnecessary movement. And he will train workers on new or more efficient procedures. And last but is not the least, he will monitor the results and make continuous adjustment. This systematic approach ensures that high level goals translate into concrete operational improvements. As for the process improvement, for example, let's look at a detailed case of process improvement in action. Consider a package delivery service where parcels were often delayed in certain facility. An industrial engineer will first create a detailed map of the current package flow. Then he will collect data on processing times at each station, identify bottlenecks where packages pile up, and he will simulate different solution scenarios using computer models, implement changes like reorganizing sorting stations or adding automated scanners, monitor results and adjust as needed. This methodical approach to problem solving is characteristics on industrial engineering. In operations management, let's examine how industrial engineers optimize an entire production system. Take a furniture manufacturing facility for an example. They will coordinate raw materials delivery with production schedules, design efficient factory layouts, minimizing transport distances, implement quality control checkpoints at critical stages, develop workforce scheduling that matches production demand, create maintenance schedules that minimize disruptions, establish performance metrics and monitoring system. Each of these elements work together to create a smooth, efficient operation. Okay, let me share something interesting about how industrial engineering works in practice. Think of it as a well orchestrated system where different components work together seamlessly. Let's start with information system is like the brain of the operation. In a modern factory I work with recently, the information track everything from inventory levels to production schedules. This information flows directly to human resources, helping managers to make decisions about shifting, staffing, training needs, and schedules. The same information system also connects to the machines on the production floor. I remember working with a printing company where their system could predict when machines need maintenance, preventing costly breakdowns. This connection is crucial because these machines then handle the materials, the raw components that become finished products. Here's where it gets interesting is that the energy component plays a vital role too. I once consulted for a manufacturing plant where we link their energy monitoring system directly to their machinery. When energy consumption peaks, the system automatically adjusts machine operations to optimize power usage. Let me give you a real world example of how all these elements work together. Imagine an automotive manufacturing plant. The information system tracks customer order and general inventory. This data helps human resources plan workforce schedules. The machines on the assembly line receive production schedules from the information system while constantly monitoring energy usage. These machines then process materials according to the exact specifications. What makes this system truly efficient is how each element communicates with others. Think of it as a symphony where each instrument plays its part, but the real magic happens when they all work together harmoniously. Does anyone have experience with similar systems in their workplace? I'd love to hear your perspective on how these elements interact with each industry or different industry. So let me take you back to 1955 when the American Institute of Industrial Engineers crafted a definition that still resonates today. I find this definition fascinating because it captures the essence of what we do as industrial engineers. Think about it this way. Industrial engineering is all about creating harmony between people, machines, materials, and energy. It's like conducting an orchestra where every element needs to play its parts perfectly. Let me share a real example from my experience. I once worked with a garment factory where we had skilled workers, modern sewing machines, and the quality materials, but their production was still inefficient. The problem wasn't with any single element, it was about how they work together as a system. What makes our field unique is no we blend different types of knowledge. We use mathematics when we are calculating production capabilities, physical sciences when we are dealing with machineries and raw materials, and social sciences when we are working with the people and the teams. I remember using all these elements when helping a food processing plant optimize their operations. We need to consider everything from the physics of heat transfer in their ovens to the psychology of worker shift patterns. Now let's talk about what industrial engineers actually do. We work with three main activities: system, design, improvement, and installation. Let's Let me give you a practical example. When I help set up a new production line, we first design the entire system on paper. That's system design. Then during the implementation, we have to make adjustments based on real world conditions. That's system improvement. Finally, we had to ensure everything was properly installed and working together. That's system installation. Here, what makes this interesting? These activities are not, sequential. They are cyclical. In my experience, even after the installation, we are constantly looking for ways to improve the system. For instance, in a recent project, we installed a new inventory management system, but we kept refining it based on user feedback and changing business needs. The beauty of industrial engineering lies in its holistic approach. We are not just focused on making machines work faster or processes more efficient. We are looking at how everything works together to create value. Would anyone like to share their experience with system design or improvement in their workplace? Okay, what I'm about to share is an interesting perspective on industrial engineering from Gary Nadler, who brought a unique human-centered approach to our field. So what I love about this definition is how it blends the technical with human aspects of engineering. When most people think of, engineering, they imagine machines and technical drawings, but Nadler saw it differently. He called it an art. I have seen exactly what he meant in our work. Let me tell you about a project I worked on recently. We were implementing a new assembly line system, and while the technical calculations were perfect on paper, we had to consider how the workers would interact with it in real life. That's where the art comes in. Nedla emphasized three key areas that I find particularly relevant in today's industrial environment. First, there's the scientific approach to management. I remember working with a manufacturing plant where we need to improve productivity. We didn't just make random changes, we used scientific principles to analyze data, test hypotheses, and measure results. It's like being a detective, but not with the numbers and the processes. So the second aspect that Nedler highlights that which I find incredibly important is understanding the human and psychological factors. Let me give you a real example. We once redesigned a workspace that was technically efficient but was causing stress among workers. By considering psychological factors like personal space and natural movement patterns, we not only improve comfort but also saw increased productivity. Finally, there's process design and continuous improvement. This is not just about making one-time changes, it's about creating systems that can evolve and improve over time. In my experience working with various companies in Myanmar and Southeast Asia, the most successful implementations were those where we built in mechanisms for continuous improvement and feedback. What makes Nedler's definition so powerful is that it reminds us that industrial engineering is not just about efficiency and numbers, it's about creating environments where both technology and people can perform at their best. I have seen firsthand how considering all these elements together leads to more sustainable and successful solution. So in here, let me explain how industrial management connects with the industrial engineering through some real examples I've encountered in my career. Industrial management is like the strategic partner to industrial engineering. They are so closely connected that sometimes it's hard to tell where one ends and the other begins. I remember a project where this relationship became crystal clear to me. Let me share a story from a garment factory I work with. We had to look every aspect of their operations, starting with their workforce. The challenge wasn't just about having enough worker, but it was about having the right skills in the right place at the right time. This is where workforce management comes into play. Then there's the material aspects. In this same factory, we had to ensure that the fabric, the threads, and the accessories were available when needed, but without tying up too much capital inventory. I remember implementing a system that helped the track, materials from order to delivery, significantly reducing their storage costs. When it comes to machines and technology, it's not just about having the latest equipment. I once, worked with a company that has invested in expensive machinery but wasn't getting expected returns. We had to develop a comprehensive management system for maintenance, operator training, and performance monitoring. The method part is particularly interesting. Let me tell you about a food processing plant where we completely reimagined their operational strategies. We were not just looking how things were being done, we were questioning why they were being done the way in the first place. Money management ties everything together. Every decision we make has financial implications. I recall a project where we had to balance the cost of automation against labor costs, considering both short-term investment and long-term savings. Finally, there's knowledge and information management. This has become crucial in modern industry. I work with a company that was losing valuable insights because they were not properly documenting their processes and learning. We implement a knowledge management system that help them capture and share the best practices across their organization. The beauty of industrial management is how it weaves all elements together. It's not enough to optimize each element individually. They need to work in harmony. I have seen companies achieve remarkable results when they manage these aspects as an integrated system rather than separated components. Would anyone like to share their experiences with, imaging or managing any of these aspects in their own work environment? I'd be interested to hear what you have dealt with, challenges of balancing these elements. Let me share you the core functions of industrial management, and I will illustrate these with real situations I have encountered in my career. Industrial management and industrial engineering walk hand in hand, like two-sided coin. I've seen this partnership create a remarkable result in many organizations I've worked with. Let's talk about planning and organizing first. I remember working with a manufacturing plant in Mandalay that was struggling with the production delays. The issue wasn't a lack of resources, it was about how those resources were planned and organized. We implemented a structured planning system that mapped out everything from raw material delivery schedules to workforce deployment. That transformation was remarkable. Production efficiency improved by 40% within 3 months. When it comes to directing and controlling, I am reminded of a project at a food processing facility. They had excellent plans on paper, but execution was a challenge. We focused on developing clear communication channels and implementing control measures at critical points in the production process. Think of it like conducting an orchestra. Everyone needs to know their part, stay in rhythm. Now there's what I find most fascinating: transformation of imports into value added products. This is where magic happens. I work with a furniture manufacturer who was using the same materials and machine as their competitor, but we help them reorganize their processes to create higher value products. It's not just about making things, it's about making things better. I remember one particular case where all these functions came together beautifully. We were working with an automotive parts supplier. Through careful planning and organizing, we structure their operations for maximum efficiency. Their directing and controlling functions ensure everyone knew their roles and maintained quality standards. And the transformation process, they went from being a basic parts manufacturer to a preferred supplier for major automotive companies. The key lesson I've learned is that these functions are not separate activities. They are part of an integrated system. When they work together smoothly, that when you see real industrial excellence. Would anyone like to share their experiences with any of these management functions? Perhaps a challenge you face or maybe a success story? Okay, now let me explain the fascinating relationship between industrial engineering and industrial management through some real world experiences I have encountered. I often think of industrial engineering and industrial management as two dancers performing a perfect duet. Each has its own role, but together we create something remarkable. Let me share a story that illustrates this beautifully. I once worked with a large manufacturing facility that was struggling with efficiency issues. The industrial engineering side of our work focused on optimizing their production processes. We analyzed workflow patterns, identified bottlenecks, and implemented technical solutions to reduce waste. I remember specifically redesigning their assembly line layout to minimize unnecessary movement and improve productivity. But where it gets interesting, having the perfect technical solution wasn't enough. This is where industrial management came into play. We needed to ensure the people working in the facility understood and embrace these changes. We had to manage training programs, handle resources allocation, and make strategic decisions about investment in new technology. Let me give you another example. In a food processing plant, our industrial engineering team developed an automated quality control system, a beautiful piece of technical optimization. However, the success of this system depended entirely on how well it was managed. The management team had to handle everything from staff training to financial planning for maintenance and upgrades. I find it particularly interesting how these two disciplines approach problem solving different yet complementarily. So the industrial engineering asks, how can we make this process more efficient? While industrial management asks, how can we ensure our people and the resources support this efficiency? One of my favorite projects involves a garment factory where we could see this relationship in action. The engineering team optimize the cutting and sewing processes, introduction new technologies and general methods. Meanwhile, the management team focus on training programs and resource schedulings, maintaining quality control systems. Think of this way, industrial engineering creates the blueprint for success, while industrial management brings that blueprint to life through people, resources, and strategic implementations. So let me wrap up today's discussion by connecting everything we have learned, with some real world experiences I have encountered throughout my career. Think about the way industrial engineering optimizes all those production factors: people, machines, materials, information, and energy. I remember working with a beverage manufacturing plant where we could see this optimization in action. We had skilled operators working with automated filling machines, using raw materials that arrived just in time, all coordinated through a digital transformation system that monitor energy usage. The result was seamless operation that increased productivity by 30%. The application of scientific principles in industrial engineering is not just theoretical, it's very practical. I once helped a pharmaceutical company improve their production line efficiency. We used time study and statistical analysis and motion studies to identify improvement opportunities. But here's what fascinating is that these scientific principles led to very human solutions like recent designer workstations to reduce operator fatigue and improving materials flow to prevent bottlenecks. Let me share a particularly memorable example of industrial management in action. A furniture manufacturer was, struggling with coordination between their different departments. We implemented a comprehensive management system that started with detailed planning of raw material requirements, organize production schedules around market demands, provide clear direction to team leaders, and establish control measures at critical point. Within 6 months, their order fulfillment time dropped from 3 weeks to just 5 days. What I find most exciting about our fee is how these elements work together. I recently consulted for a food processing company where we could see the perfect marriage of engineering, optimization, and the management principles. The engineering team optimized their production line using scientific principles, while management team ensured that resources were properly allocated and that everyone was working toward the same goals. The key message I want you to take away in this: industrial engineering provides the tools and methods for optimization, while industrial management ensures that optimization are successfully implemented and sustained. I've seen this partnership create a remarkable transformations in business across various industries. Would anyone like to share their thoughts on how these principles might apply in their own work environment? Or perhaps you have questions about implementing similar improvement in your organizations.